engineer, it's a great thing that the capacity has increased, but all these modes may mix. So you need to work out the corresponding math or the algorithm which will invert the mixing matrices. So that's another challenge for the signal processing engineers. Then, as you increase the signaling rate, symbol rate. So you are currently for 100 Gbps, you are running at 25 gigabaud, but then today's state of the art uses 96 gigabaud, close to 100 gigabaud with 16 QAM with 100 gigabaud. You're already at 400 gigabits per second, and with polarization multiplexing, you're at 800 gigabits per second, right? That's a kind of data rate. As you keep increasing the data rates, there are many more impairments which we have not covered in the course, which we may not have covered in the course, that will start coming into play. For example, your whole communication relies on the fact that you have a constellation where the in-phase and the quadrature components, by the nature of their definition, they are at 90 degrees, right? You draw the constellation. When you draw the constellation, you say that my in-phase component and my quadrature phase component is exactly at 90 degrees. That's why I'm able to transport a particular constellation the way I want. But then when the data rate increases, you will be transmitting the electrical channels before it reaches the modulator. The in-phase and the quadrature components may have a small delay. So that will lead to in-phase quadrature delays. It may have a skew in the sense that the I and Q may not be at 90 degrees. So all that become more and more evident as you increase the signaling rate. Similarly, the laser's phase noise. The phase noise, because of the phase noise, you know that the constellation keeps dithering, and the phase margin that you can support becomes much tighter, smaller as you increase the number of constellation points. The laser's phase noise become more critical, chromatic dispersion becomes more critical, nonlinearity becomes more critical, right? So a large bunch of signal processing algorithms need to be reworked. What I taught you in the course is very basic, fundamental for 100 gigabits per second, QPSK and polarization multiplexing. So there's a scope for signal processing engineers to work in the domain of optical communication. Then there's a large scope for RF engineers to work, because as the data rate increases, the bandwidth increases. So, you need to be able to design your RF boards which are compatible to high bandwidths. And there's a whole bunch for FPGA engineers, right, who have to now work on signal processing algorithms in real time. You parallelize it, you do a multi-core processing, and so on. Then there's a lot of challenge for the laser engineers. As you go to higher and higher signaling rates, you need very low noise lasers. And how do you make those lasers? The current lasers that are available in the market are the ones which are finally limiting your data rate, or how many constellation points you can have. So how can you make more improvement in the lasers? How can you make more improvement in your photodiodes? How will you bring the noise in the photodiodes down, right? So optical communication engineering is kind of having a rebirth. We are trying to look at all these aspects, completely taking a relook at all these aspects to see how we can improve the data rates. Because, on one hand, your 5G and the 6G all are increasing the data rates with the end user. And so your backbone fiber should support all that data rates. So unless we do what is necessary to keep scaling up in the optical fiber, none of the 5G and 6G is going to be a success, right? So there is a lot of scope for R&D in terms of simulations, in terms of experiments, in terms of device development, in terms of subsystem development in this domain, right? So it's an exciting area. So the course may have, depending on what is your background, the course may have looked easy or difficult for you. But fortunately or unfortunately, we need to have a basic understanding of all, little bit understanding of all of these to be able to be a successful fiber optic communications engineer. I will leave the floor open to your questions on any parts of the course or what you would like to know about further before I start talking again. You need to unmute your mic and speak so that I can answer your specific questions. Because as far as lecturing from me is concerned, you've heard enough of me. So I see 3 co-hosts and posts, and I see Arjun, who is a TA. From the rest, if you are a registered student, you have to please ask your question. Would they be able to unmute and ask, or is it only through chat they can ask?
They can unmute.
They can unmute and ask. Okay. Look, there are not going to be any tips for the exam. That's not what is the purpose of this session.
Good evening. Hello.
Yeah.
Yes, ma'am. Good evening, ma'am. I have a question regarding simulations of finding modes of fiber of waveguides which are not exactly cylindrical shape. So, as far I know that we can simulate that in console multiphysics and other softwares like ANSYS numerical. So how do we decide that which software is will be appropriate for the geometry that we select? Suppose we have a non-standard geometry like ridge and other arbitrary geometries. So how can we decide which software will be most appropriate for that purpose?
Okay. I'll give you an easy answer and a difficult answer. Okay. Difficult answer is that you've already identified the 2 popular softwares that does COMSOL and also numerical. Right? Numerical is taken over by ANSYS now. So one way is to actually go and look at how each one of them is solving your problem. Is it finite element method? In fact, as far as my understanding goes, both of them use finite element method to solve for the modes. Now, the question is, what do you want to do with it, right? Do you want to do a frequency domain analysis? Do you want to do a time domain analysis? Do you want to find out the crosstalk? You want to do propagation, right? Or is it that you assume that your modes are, your waveguide is, what do you say, uniform across Z? You can assume that along the Z there is no change, right? So based on that, sometimes what could happen is that both of them may be insufficient, in which case you will have to do a part of it in numerical or COMSOL, and the other part you may have to write your own codes for it, right? So if you ask me, what would you need to simply solve the modes of a fiber or asymmetrical structure? I would actually say the cheapest way to do without paying the license fee for any of these is write down the structure. These kind of, the easiest way people do is finite difference methods also, right? If you assume that along the Z it is invariant, finite difference methods are used to solve the electromagnetic wave equation. And some of these codes are even available in open source. A lot of books on, fiber optics or even numerical method books they give you the finite difference method algorithm to solve for any non-uniform structure. So if you have a little bit of patience, it may be worthwhile to write your own codes in Python or MATLAB so that you understand what's going on. The easy answer is you ask around. What have other people used? Look at papers. What have other people used? But that's quite lazy to do that way because other people may have used specific software because of various different reasons. Maybe the license was available. Maybe different reasons. So I would say go by the difficult path. Understand what do you want to achieve out of this. What do you want to do after solving for the modes? Do you want to study crosstalk? Do you want to study cutoff conditions? Do you want to study propagation? Right? Based on what you want to do, you can decide what software to use. And like what I said, my recommendation would always be use your own codes. If you have, if you can spend, because all these methodologies and algorithms are already available in open source. The question of adapting it to your requirement, and this gives you definitely much more learning than what you would get if you just define a structure and click a button saying solve the modes, right? You would not get the depth of understanding of what that spews out, whether it is making sense, is it correct, not correct. All that you may not appreciate unless you write it yourself. I hope that answers your question.
Yes, ma'am. Thank you.
Any other questions? Okay. If there are no questions, I will just stop the session with one announcement that if you can convince me, if you score reasonably well in the final exam and the overall score, we will definitely provide you with an opportunity to carry out your internship in December or next summer based on your availability. So you feel free to write to me after you finish your exam and get your grades. And if there are no more questions, we can sign off. All right, thanks to the NPTEL team and to the TAs, and feel free to write to me if you wish to work in any of these areas. Thank you.
Thank you.
Hi, Sona.